builds. The CI system can take care of all that and leverage its ability to integrate with tools like Docker and Kubernetes to take full advantage of the power of the cloud without burdening a laptop. Best of all of this work is automated, which frees up the developer to move on to other tasks while the build and test completes. Continuous delivery or CD is the next step, which is an evolution of continuous integration and focus on addressing the next two phases of our software development lifecycle pipeline, which is the review and staging. We have our automated build and it passes all our tests. That's great, but why stop there? With continuous delivery, we can add the capability to take that build and deploy it out to an environment like staging. This ensures that the staging environment is always reflective of the latest changes to the branch and it is available as soon as possible for the broader team of stakeholders to review and participate. Integrated tests, performance tests, UAT testing, anything else that needs to occur here cannot be done. Once that is completed, we can then click a single button and that same build then goes on to be automatically deployed to production. This results in a few key benefits. First, we have a build that is always ready to be deployed. It has passed all our tests and has been running in staging. A simple button click is all that is needed to elevate it to production. And best of all, the process for doing this is reliable. We have been using it for all the deploys so far, and it's even checked into the repository. The second key benefit is that environments are updated and spun up quickly on demand. With review apps, the second developer creates a branch, we can spin up an environment to run that code. This means they can start collecting feedback from other stakeholders immediately, like product, QA, documentation, and more. No more waiting potentially weeks for an integrated testing environment to arrive. This will reduce the barriers to collaboration and shifts the feedback as early as possible in the cycle where it's cheapest and easiest to address. Which brings us to continuous deployment, which is an evolution of continuous delivery and relates to our production stage. The key difference here is that the continuous deployment removes the manual checkpoint before pushing builds to production. This model is most relevant when you have been operating with continuous delivery and have built the confidence and maturity in your operations to allow changes to begin to flow directly to customers. The most important advantage here is that the feedback loop is as short as possible. So if a prospect has reported a critical bug that is preventing them from signing, a developer can fix the issue with the changes live shortly thereafter. That is a beautiful and powerful thing, and it also reduces the amount of time the product improvements your developers have built sit on a shelf, waiting to be deployed. The cycle of development to testing to deploy is highly efficient, freeing up your team to focus on creating value and not on repetitive tasks. So now I'm going to talk about the pipeline architectures, and I'll cover some of the possibilities we have, as you can see here on the agenda. Let's start with the most common type of pipeline, which is the basic pipeline. And as we can see on this example, all jobs need to be completed before the review app gets deployed. We have a couple of tests, but even though they are running in parallel on separate runners, they are still blocking the deploy job. A common refrain for this type of pipelines is that they are slow, and this is a good opportunity to investigate the pipeline architecture and dive into why this is slow. Those pipelines can be made more flexible via allow failure and manual options, and this is most common and easiest type of pipeline to write. On this example, even if the test B fails, the pipeline proceeds, but we need someone to click the play button to deploy the application. Then we have DAGs or directly acyclic graphs, and those can help solve several different kinds of relationships between jobs within a CI/CD pipeline. This can happen when you are handling multiple platform builds or complex webs of dependencies, as in something like an operating system build or a complex deployment graph of independently deployed but relatable microservices. Additionally, a DAG can help with general speediness of pipelines and helping to deliver fast feedback. By creating dependency relationships that don't unnecessarily block each other, your pipelines run as quickly as possible, regardless of pipeline stages, ensuring output, including errors. Because these pipelines might get a bit complex, the needs visualization makes it easier to visualize the relationships between dependent jobs in a DAG. This graph displays all the jobs in a pipeline that need or are needed by other jobs. Jobs with no relationships are not displayed in this view. Then we also have parent-child pipelines, and they are very similar to multi-project pipelines, where a pipeline can trigger a set of concurrently running child pipelines, but within the same projects. Those are useful for running non-dependent, long-running jobs like code scans, or building and deploying front-end, back-end services separately. Here we see the same pipeline that had the scan and test stages moved to child pipelines. And with this, we don't have to wait for those jobs to complete before we get our review app. In this case, if you have a DAST job which requires a review app, um, that will still be a separate stage and we'll still need the review app to complete before we can perform the following steps. This type of architecture is also useful for monorepos. We can leverage some options to run the pipeline only if you have some changes in some specific files, and by adding the depend option, we'll hold the run until other pipeline finishes. So then we also have dynamic pipelines. And here, instead of running a child pipeline from a static YAML file, you can define a job that runs your own script to generate a YAML file, which is then used to trigger a child pipeline. The configuration here is split into smaller child pipeline configurations, which are easier to understand and will reduce the cognitive load to understand the overall configuration. So if you look at the logs, here you'll be able to see where exactly the replacement happened. We already talked about parent-child pipelines, which are very similar to multi-project pipelines, but I just wanted to showcase that with GitLab CI/CD, you can set these up across multiple projects. Um, those are useful for larger products that require cross-project interdependencies, such as those adopting microservices architectures.
So now that we covered the basics of GitLab CI/CD, the concepts and the tooling, let's talk to our engineers and see how we at GitLab use those features. We have today with us for the CI part, Remy from the engineering productivity team, and he will try to shed some light on our processes around CI. So Remy, I know that when creating CI config files, usually the struggle is to find a good balance between being secure to being flexible and efficient. So can you tell us how do we do this in GitLab?
Good question. So first of all, we try to dog food as much as possible what GitLab is offering. So every time there's a new feature on the CI front, we try to dog food it as much as possible, and that way we can also improve the feature over time. So I would say for the efficient part, the things that are the most powerful are, in my opinion, at least for us, are the rules keywords and the needs keywords. So if you want, I will go through the first one, the rules keywords. So I share my screen now. So the rules keyword allows you to define specific conditions under which job would run or not. And for us, it allows to kind of define 4 types of pipelines. And before we had this rules keyword, basically we didn't have that. It wasn't possible. So these four types for us are the documentation one, which basically runs documentation related jobs. Then and it takes around 6 minutes to finish, so it's a faster pipeline type that we have for the project. Then we have what we call the code pipeline, which runs our test suite, most of our test suite, as well as a lot more jobs, but you can look at the details if you want. And this one takes around 60 minutes to finish, or even a bit less these days, like 50 minutes, I would say. Then we have the front-end pipeline type, which is the same as the code one, but with a review app that is being deployed and against which we run as well end-to-end tests. This one takes 67 minutes on average. And then we have the longest pipeline type that we have is the QA or end-to-end test pipeline type that kind of does the same as the previous one, but that in addition creates a whole GitLab package and runs end-to-end test against it. So these are the examples of what you can do with the rules keywords. You can really define specific types of pipelines with a set of jobs that you need only for specific cases. And yeah, so for us, that works really well. And it really, yeah, got us to the next level of pipeline atomicity, I would say, compared to before, where we would have only one pipeline type basically for everything. Then we have the needs keywords, which allows to optimize when a job would start, in the sense when in the sequence of jobs it would start. And an example of how you use it is this. You write needs and then you specify the jobs that you want to depend on. So that allows to depend on a specific set of jobs that needs to run before the job that is dependent can start itself. And basically what you can do with that is that you can ignore the stage in which a job is and only rely on the needs requirements. So that allows to start a chain of jobs independently from the stages that you have defined in your pipelines. And that's pretty useful and that's pretty powerful as well. And one thing to note is that you can also define, you can also depend on jobs without downloading the artifacts of the jobs. So in some cases, it's useful, like maybe you want to wait for a job to finish, but you don't want to download its artifacts. That's further optimization that you can do. One challenge that we face in regards to security and stability of our pipelines is the testing of the CI configuration itself. So at the moment, we don't have a good way to test our CI config. So we mostly rely on our own knowledge of the config and kind of creating pipelines for the cases that we want to test. But ideally, and I think that's on the roadmap for the pipeline authoring group, ideally, we would have a way to simulate pipelines in different contexts. So for instance, you could say, let's simulate a pipeline for a merge request with this set of changes. And you could see what's the jobs that will be created and what's the pipeline that will be created basically. So that's something we are kind of waiting for, and we will be the first users for this feature, I think, internally.
Right. So I understand that we have 4 types of pipelines that we defined using rules and needs keywords. Now, going specifically about the rules keyword, what kind of rules are we using now, and what does it help us achieve?
We use the rules that allows to know the context of a pipeline, in the sense that, does this pipeline run in the context of a merge request, or is it a scheduled pipeline, or does the branch name matches a specific pattern? So for instance, stable branches or security branches. So this is one kind of rules, I would say. It's based on the context. Then we have other rules that are based on variables. So any other variables that we could set on the project, or even in specific merge request or whatever. But yeah, so that's the rules. That's the variables rule. And then we also have the project and server rules. So in some cases, we don't want to run a job on a specific project, or we only want to run a job on a specific server or GitLab instance, because we mirror our projects in several instances. I don't want to run all the same jobs on all the same instances. And the last one is probably the most important ones in terms of pipeline shape, is the rules that defines when to run a job based on specific change on a merge request. And as you can see here, we have a list of patterns that we use for specific jobs. So for instance, we have the DB patterns that's used for running specific DB jobs. Or we also have CI patterns that for which we will actually run specific CI related jobs. And yeah, so these are the kind of the 4 types of rules that we use. And they are all defined. If you want to take a look, if you are curious, they are all defined in this file, in the main project. So that's quite a long file. But yeah, basically we have these conditions, these if conditions. Then we have the patterns that we define. And then we have the actual rules definition, which are using the if conditions and the changes pattern. So this is an example here. And yeah, I think that's mostly it.
Right, thanks for that. Now we know that as a general rule, stages run one after another and jobs run in parallel. But we also have the concept of parallel jobs. And parallel jobs, by that we mean duplicated jobs, where we can set a certain job to get duplicated, and those duplications run also in parallel. So how do we use that feature, and why does it make it more efficient for us?
So yeah, what it does is basically it's like it will duplicate the job, if I can say that, on different nodes. and it will set two variables, the CI node index and the CI node total. CI node index is the index of the node that is running. So if you say, let's run on 5 parallel nodes, the indexes will be 1, 2, 3, 4, 5. And the CI node total is the same for all the jobs. It will be 5 in that case. And that's mostly it for the parallel feature, in the sense that for the rest, you have to handle it yourself. Like it's up to you to define how the parallelization works, given these two variables. And so one tool that we use for our aspect test. So this is our test for our main Ruby on Rails app. A tool that we use is Knapsack. And yeah, actually I have, so we have a small documentation on how we use it internally. And I won't go into details, but basically what Knapsack does is it takes the list of all your test files. It kind of let's say divide it by the parallelization that you want, and then it spreads the test files on each job that is parallelized. And yeah, without this feature, we would like our pipelines would be a few hours long. So fortunately with that, it's less than an hour. And we use this parallelization feature for our tests, as well as to build our front-end fixtures. So we have front-end tests that needs like HTML fixtures. So we use the parallel keyword for that as well, because we identified that the job was too long, and using the parallelization basically makes it like twice as fast in this case.
We're talking about efficiency. What about our cache? How do we build our cache, and what is the caching strategy we use in our CI pipelines?
So again, we have documented internally how we use the cache for our main project, and basically we ended up with a strategy, which is that jobs by default should only pull the cache. They should never update it, because uploading the cache is adding, could add a few minutes in some cases. The second rule is that the cache should, like a job should be able to run without any cache. So the cache shouldn't be something that's critical for a job in terms of the job finishing, not the job being fast, I must say. And then we have a set of caches that you can see here, and that are actually defined in this file. And the caches are specific to different jobs, obviously. Like we have a cache for, let me just show you. We have a cache for the Ruby gems, for instance, which lives under vendor Ruby. We have a cache for node modules here. We have a cache for Go packages, and so on. And what's interesting is that we use the multiple cache feature that was introduced in 13.12. And what this feature allows you is to really define very atomic cache, and to then combine, like, this one is the cache and this one is another cache. So you can define multiple caches per jobs, And that allows to be very atomic with what jobs, like which jobs needs which cache. And yeah, and just for to finish on the cache, the last part of our caching strategy is to update the caches every 2 hours, because in most cases, a merge request is totally fine with a 2 hours old cache. And even in the case where it updates a dependency, it will just have to actually install the missing dependency. So that's totally fine to update the cache every 2 hours in our case, at least.
Right. So I see here that our CI config is splitted basically for smaller chunks of specific CI config files. Each is taking care of a different area. How is it working together? We also have CI config files that take care of the overall configuration. For example, the rules YAML. How is it working with having different code owners on different files, permissions, etc.?
Yeah, basically everyone that has access to the project can edit the rules, but then we have specific, as you said, we have specific code owners for specific CI config files. So if I look at the code owners file, these are the rules. Basically, these ones, you can see, for example, the docs related CI config is owned by my team as well as the technical writing team, and likewise for other files here or there. So yeah, basically we divide our CI config into logical files, like area of area of work, like we have one file for front-end, one file for Rails related tests, and that allows us to have specific code owners as well.
I've explained this during the CI introduction today, um, but I'm curious, how do we use the need keyword, and when do we prefer to use parent-child pipelines?
Yeah, so we currently in the main project, we don't really use the parent-child pipeline, but we do use the downstream pipelines. So we trigger pipelines in downstream projects. And so, for instance, that allows us to trigger a pipeline in the Omnibus GitLab project, which takes care of building a package for GitLab based on the changes from the merge request. And then this pipeline itself will trigger another pipeline to run end-to-end test against the package. So in those cases where you really need another project to do specific actions, I think it makes sense to use to trigger the downstream pipelines. And for parent-child pipelines, I don't think we have a good use case right now in our main project. But I would say you would do that to kind of separate logically your CI config into very specific chunks, and to run specific jobs in a separate pipeline, but that's still part of the main pipeline. Yeah, that would be my answer.
Sounds good. And we talked a lot about making things more efficient today. When thinking about making them more secure, how do we run end-to-end tests, and when do we do it?
Yeah, so that's exactly what I was describing. So thanks for the question. I can go into more details. So basically, that's this page describe exactly the downstream pipelines that we trigger. So that's kind of complex because we trigger a build in the Omnibus GitLab Miro project, which builds a Docker image for a GitLab Docker image for the change in the merge request. And then once done, it itself triggers a pipeline in the GitLab QA Mirror project, which actually spins up the image from the previous pipeline and runs end-to-end tests against the container. And these end-to-end tests are run as part like are written with an internal framework that we developed, which is called GitLab QA. Very simple. But yeah, that's so we don't do that for every merge request because that's an involved process, and that's actually the pipeline type that I was speaking earlier. This pipeline type is taking like 100 something minutes to finish. So it's kind of long and involved. So we only run it either manually or upon specific changes that warrants to run that.
Cool. Thanks for that. And last question for me. I know that many customers are interested in how we use the Danger bot. Can you tell more about it, what it is, and why are we using it at GitLab?
Sure. So yeah, the danger bot, we call it danger bot because we are actually using an external tool, which is called Danger. And what danger allows you to do is to run like checks, or you can actually do a lot of things. Like it's very open. It's up to you to write your own rules. And I need to say it's an external tool, so it's not shipped as part of GitLab. We would love to, but it's, as currently it's not the case. And one of the main feature, like one of the main rule that we use with Danger is the reviewer roulette, which is described here. And basically, the reviewer roulette is suggesting reviewers and maintainers. So in our case, for the GitLab project, reviewers are people that review a merge request, and maintainers are also reviewing the merge request, but they have the right to actually merge. So that's the difference. And yeah, basically, the reviewer roulette is um, is something that we developed ourselves, and ideally that would be a GitLab feature, and I'm sure it's in the pipe um, for the code review group. But yeah, you need to check with them. But yeah, if you want to use Danger, yeah, feel free to check out our own documentation, and then it's up to you to basically like develop your own rules. For instance, we have rules to ask for specific labels to be set in some cases, or we also have rules that actually add labels based on the changes. You can do a lot of creative stuff with Danger. So feel free to use it, and hopefully we'll have something implemented in GitLab soon.
Thanks. I hope this was helpful. Thanks for your time. And
Thank you.
we'll be discussing next the CD part as well at GitLab.
So to continue to the CD part of our conversation, we have here with us today from our delivery team, Amy, the engineering manager, and Alessio, the staff backend engineer. And they will help us understand how GitLab does continuous delivery, continuous deployment. Now, I know we have two distinct processes. One is dedicated to the self-managed to the packaged version, and the other for GitLab.com, the SaaS solution. How is it going? Maybe you can explain a bit.
Sure, Hosna. This is a great question. So if you don't mind, I will start with GitLab.com because it's a basic part of how we make the package for the customer on the 22nd every month. So we used to refer to this as auto deploy. So basically every day we have a schedule, and roughly every 5 hours, so 5 times a day, we create a package. This means that we start by finding the latest green commit on master on the relevant projects, and then we create packages out of this. Then when the packages are ready, then we move on to deployments, and we do staging first, then we do canary. Then we have a baking time, which is about 1 hour, where we monitor the status of the fleet of the deployment. And then here it comes into play the release manager role, which is a rotation role in our team. We have a manual promotion where after 1 hour of baking time, we check metrics, we check the status, and if a release manager is around and is available, he promotes the build. And so the build goes into production. So this roughly give us 4-5 deployments each day. It really depends on time zone, incidents, and things like that. And so this means that engineer working on the code base can expect to have their code deployed in GitLab.com within 12 hours, 1 day, kind of. And this is basically the mission of our team. Then with this process in place, we can talk about how we release the packages every month. So the auto deploy schedule is basically it happens every working day. And then the milestone, when we release a package for the milestone, basically the milestones start on the 23rd. So the first day after the release, and it ends on the 22nd. In this period of time, every day we deploy packages up until more or less the 20th of the month. So kind of 2 days before the release date, when we do, let's call it a code freeze. Basically on that date, we pick the last deployment that was on GitLab.com, and this is where we breach the two processes. The last deployment that was successful and stable on GitLab.com became the branching point for stable branches. So from around the 20th of the month, we branch off, and from that point on, we only fix high priority and high severity issues. And this gives us a couple of days for the last minute fixes and preparing the packages so that we can release it to our customer on the 22nd. In the meantime, so 21st, 22nd, and so on, we keep going on with the auto deploy process, but just the history of the things that we release this month and what happens on GitLab.com diverge, and they will converge again on the 22nd of the next month. So yeah, this is the bread and butter of release management at GitLab.com.
So it sounds to me like we have quite a complex process there. How do we make sure that everything works as it should, or when it doesn't, what do we do when we talk about things like rollback, etc.?
Okay, this is a great question. So the thing is that we have several projects involved in how we package and deploy GitLab.com. The most important one is Release Tools, which is a custom tooling project that our team owns. And basically, we make use of CI for handling our tagging life cycle. So this means that we tend to have as less as possible manual action. And if there are manual action, they are based on checklists that are generated through code. So all of the things that I'm talking about is publicly available on GitLab.com. So maybe we can share the link to this project. The part that is not publicly available are the pipeline themselves, because we run them on another instance. just for having isolation between GitLab.com and the infrastructure that we're using for running and deploying GitLab.com. But the code is there. So the thing is that the project itself has several automation scripts for generating tracking issues, for things that have to be done for the monthly release, or keeping in sync the release manager rotation so that the team members in delivery that are supposed to be release managers for this milestone are properly assigned to issues, and they are able to receive Slack notifications and things like that. And so because this is written in code, then we have tests. So when we change something, we run tests on our own script. So we make sure that they behave as expected. And then we make use of pipeline schedule, which is a feature of GitLab to orchestrate the timing for this operation. So as I was referring before, we have 5 hours during the day where we run the new deploy creation, and this happens automatically. We only get a notification if things goes wrong. Something goes wrong, then we are notified. As I was mentioning before, the only manual action in this step right now is the promotion of a package. So deployment to production requires manual action, as well as creating the stable branch, which is the thing that happened around the 20th. Is a manual action, is a description to the release manager to make a choice of when creating the stable branch, because it's also based on stability of the package. This covers the monthly milestone, but customers knows for sure that we also have security fixes, patch releases. So there are extra stuff that are based on how we release. All of these are still automated by release tools. So basically, there are checklists and there are CI commands that we can run to merge fixes into stable branches, preparing packages, and basically starting all this process. So everything is automated. Maybe the entry point is not.
Cool. Thanks for that. I also have a question on my side. With us having the typical releases, the security fixes, and all that, are there any actions we are taking to manage the complexity of this process?
Sure. So I was briefly mentioning before that we have several projects. So we have several projects. We have also several instances of GitLab.com that are involved into this. So let's start with entry points to this process. So as a release manager, if we want to start something related to deployment or release, we usually interact with our tooling using chatops command. So we have a set of chatops command that we run. They go through the GitLab instance, and GitLab instance runs CI with the chatops configuration, and they start the process. Now, because we have one chatops entry point, but several projects, we heavily relies on bridge jobs, which is another features of our CI, which basically allows us to trigger a pipeline into another project from a parent pipeline. And this is extremely helpful because I'm trying to give you a brief understanding of what we have here. We have chatops that interacts with release tools, for instance, but then release tools is only an orchestrator here. So the main goal of release tools is having checklists and knowing the procedure for having a package, but then it doesn't deploy, it doesn't create packages and things like that. So in this case, from release tools, we create packages, omnibus packages that our customer installs on virtual machine on bare metal, as well as Kubernetes images, so Helm charts and things like that. Those things happens in other projects that we refer as packagers. So release tools triggers pipelines on packagers. Then we wait for the packages to be ready, and then we move on and say we want to deploy on staging. But again, staging is not, deployment is not something that release tool is managing directly. So we have another project that is specifically designed for handling the complexity of deployment. This can go down boxes and boxes because basically when we go on deployment, we have a mixed environment with virtual machines and Kubernetes. So Kubernetes deployment as well is into another project. And so with bridge jobs, we are able to basically drill down in the pipeline. So depending on what is your task or what is your day-to-day activity, you can watch the process of a specific level, or as a release manager, you can just watch from the release tools point of view where everything is triggered, so you can just drill down into the specific details. Again, the same thing happens for QA. We have another QA project, so we have other pipelines that get triggered that are running QA on the environment after deployments. And that basically that's the idea. Bridge jobs gives you the ability to trigger something and also wait for the result of the pipeline that you triggered.
Yeah, absolutely. Thanks for that explanation. Another thing is that we always talk about working in iterations and improving our processes. What metrics do we use when working to improve the release process, such as Dora4 metrics, mean time to merge? Is there anything we can suggest to get those relevant insights about our processes?
Yes, absolutely. So as Alessio mentioned, a lot of our work is around packaging, like things being packaged and changes going out to users. So the main metric we are tracking against with all of our work is mean time to production. And we have this in the handbook. Let me, I'll just share it with you. It's available, publicly available, but okay, so hopefully you can see this. So it is one of our infrastructure department metrics. And what we show here, we can see we've been tracking it for a couple of years now. And what this is showing is the amount of time, so the mean time that it takes for an MR, once it has been merged, to reach production. And so there's a couple of interesting things that we can see along the time here. So back sort of early last year, we can see numbers were pretty high up. These are in hours. And then we can see in May 2020, this is where we made a big switch and we moved to daily deployments. So GitLab.com was receiving daily deployments. So we can see a huge jump there. So not a trivial change, like lots of tooling change, lots of process change to allow us to kind of coordinate this and make sure these changes are as safe if we're doing them once a week or once a day. And then what we did then following this, so we use this metric within the team on a weekly basis. We do a review of how has the current week been. It's close enough then that we can sort of remember, oh, on Tuesday we had this thing that delayed us, or on Wednesday we didn't get a package till sort of lunchtime, or whatever the things are still present enough for us to be able to identify fluctuations in our metric. And what became clear between May and August was one of the biggest delays that we were having was around security releases. And at the time when we prepare the self-managed security releases that go out each month, is they were blocking our deployments to GitLab.com. So then we started doing a project and we managed to remove the blocking nature. And we can see the drop here from 39.1 down to 24.4. So we use this and iterate through. So each time we come along and we sort of look back over the last few weeks, the last month or so, and what can we do next? Is there something in our pipeline we can make faster? Is there a particular pattern we're seeing? Are there certain types of things that are slowing this down? We can just see this is very excellent timing to record this stuff. You can see we've just reached our new milestone just this month. And what we've done this month is we've actually expanded the release manager time zones. So Alessio mentioned that we have this manual promotion of the actual deployment that goes to production. A release manager must press that button to say, you know, they're online and they're ready and everything looks good. And just this month, we have expanded so that within the APAC region, we also have a release manager. So now we have 24-hour coverage for release managers during working days. So this has been our big step. but we'll continue to iterate on this. There are lots of things that go into MTTP. So this is a bit of a bundled up number which tracks what's happening, but it doesn't show necessarily what's going into that number. So MTTP is affected by pipeline duration. It's affected by incidents or other changes taking place on the infrastructure. It's also affected by release manager availability, and there are lots of things. What we're working on at the moment is distilling this down further, so we actually have really good visibility of other certain days we see things, or other certain parts of our deployment pipeline that perhaps take a lot longer than we'd expect, and we can then plan out what are the next steps that we want to go to actually start breaking this stuff down.
Thanks, Amy. This was super helpful. And it's incredible how we can correlate our initiatives with the metrics here. And congratulations for these huge improvements.
Thank you very much.
Cool. So thanks everyone for attending. Apologies for some of the connectivity issues which prevented us from streaming with better quality on some of the video parts. It was indeed hard to read, but we'll send the original video in HD after the webinar. We'll now start with the live Q&A panel with Osnat reading some of the questions that we are still missing, and inviting someone on the panel to answer it. So you may want to keep asking questions on the Q&A box, or you can also raise your hand to be invited on stage and verbalize your questions. So over to you, Osnat.
Yeah, I don't see any questions at the moment.
So we still have one open question there from Adrian regarding copy on write cache. I was trying to find any feature requests or hints on our roadmap about copy on write cache that I couldn't find yet. So Adrian, please go ahead and open a feature request on gitlab.com/org. You can explain your requirements there. And try to and I will try to get an update from one of our project managers on whether this is something that we are looking to take on our roadmap.
We have a few questions coming in. I will just verbalize it. Can job run tests in parallel? So yes, the jobs are running in parallel, and if you require a specific job to run duplicated, as we discussed on the webinar, this can be done by using the parallel jobs feature. Any more questions? You can also choose to verbalize it yourself. Just raise your hand and
I think there's a question about conditional metrics. So Eden, if you can maybe verbalize a question, that will help us answer it. Yeah, Eden, you can unmute yourself and explain what your question is about.
Hi, guys. So we use a lot of parallel metrics because we have multiple environments, and a lot of times we come into a situation that we want different rules based on the different parallel metrics. So is that somewhere on your roadmap, or is there a way already today to define different rules per different metric job?
Yeah, I think this is exactly the question that also not answered now. We do have a concept of parallel metrics jobs. So this was also presented today in the webinar. Just trying to, yes, if you look at the documentation, we do have a parallel keyword in a job that would allow you to run multiple instances of the job and pass sort of the variables into this metric so that different jobs, the same job, would run in parallel with multiple configurations. Does it make sense?
Yeah, the question is around adding rows to the different jobs. So I get you can pass different variables, but can you pass different conditions? And the second,
Can you elaborate a little bit on the use case? I'm still trying to understand what that.
Yes, sure. So think about that. Sometimes you want to deploy to multiple production environments, but based on certain scenario, want to deploy to one environment and don't deploy to the other. For example, the user is triggering from outside a different variable that tell it to deploy to one environment and not to the other. So today there isn't any way to support that, but creating different jobs to different conditions. Parallel metrics will always trigger just as different variables. You don't have an option to say trigger that parallel job, but don't trigger the other one. Conditional parallel metrics, like
conditional parallel metrics. Yeah, it's a good question. I don't think we have this. If anybody can chime in from our team.
I can chime in on this if you want. Okay, so we have some similar problem in delivery. So we were trying to deploy on different, as you were mentioning, we were deploying on different environment, and at a certain point we were exposing this feature from ChatOps, so from an outside job. So we ended up with this solution, which is basically we have parametric job in our CI where you can provide with a variable the name of the environment you want to deploy. And then we inherit from this, and we basically we have an external variable which is provided by ChatOps, which tells which environments you want to deploy and is comma separate. So you can do regular expression on this and decide if you want to run it in a specific environment or not. And then we have the deployment target, which is another variable that can't be passed from the outside, which is defined in the inherited job. So just try to make it easier to understand. Let's say you want to deploy to staging, canary, but not production. So you trigger something that has a variable. This is something like desired rollout, staging, comma, canary. Then you have a job that defines how to deploy in any environment and expect environment variable. Oh, environment is just the same word as terrible. So deploy to variable. So what you are doing is that you are only duplicating the selection logic. Basically, in your GitLab CI YAML, you have several jobs, one per environment, and they are triggers if you want to deploy in something that contains staging, and then you override the variable and say, this is a deployment for staging. So that in the end, you can just trigger a pipeline and it will run 1, 2, 3, or as many deployments on different environment as you are asking with a single variable. This is, I mean, it's how you can configure it. Is not a real feature of the product, but is how you can make this.
Okay, so we achieved the similar behavior using reference, but it would be useful if reference can have environment variable also inside of them. So you can dynamically choose what is the reference key you are trying to inject. So is that something you guys also thought about? Supporting in the reference function environment variable?
I'm not sure if anyone from the panel knows. Otherwise, we can address this in the follow-up email we will send.
Okay.
Good, thank you. We have a couple more questions coming in. The pipeline, and I will just verbalize it. The pipeline analytics are nice, but if you have child pipelines that can distinguish between different pipelines in the charts, parent versus child, are there different visualizations or a way to access the raw data? Anyone wants to take this?
Yeah, I'll also add, because I think there's a follow-up message also from Devin about are there any plans to expand analytics such as tracking time for specific jobs? So yes, we understand that sometimes it's not possible to get the full view of the analytics about your pipelines and jobs performance. Something that I would recommend, there's a great open source project called GitLab CI Pipelines Exporter. I'll type it in the answer and share the link with you over there, Devin. It's an open source project. It's not supported by GitLab, but what it does, it exports a lot of metrics, particularly on the CI pipeline and job execution. It still potentially will not solve your current problem with the child pipelines because it doesn't differentiate on pipelines, but it will let you zoom in on specific jobs. So that's an exporter that does gets all these metrics and present them nicely in Grafana. I've seen some customers use that. So we, of course, it's something we're considering of implementing further in GitLab, but already now, before we do that, you can already achieve this using that third-party solution.
I'll go to the next question. When building containers, we have separate projects to build a base container used for several other projects. Is there an existing mechanism to allow those sub-projects to run a build when the base container project is changed? I know you can use triggers to start that other pipelines, but that means continually having to add new triggers to the base container pipeline. Is there a way to tell the sub-projects to look for changes in the parent project?
I'll take this. We do have a concept of pipeline subscriptions. So you can actually do it the other way, where your child pipeline can subscribe to a parent pipeline. It would act in the same way, but the difference is that you will configure it on your base project, on your parent project to trigger the child. You will actually tell the child to subscribe to successful pipelines on parent. I'll see if I can find a link on this and share this also in the chat.
And moving on, we have one last question in the chat. Use case, maybe assume I have build job, for instance, nvn clean install, and I have 2 tests. At the moment, tests run in sequence, test 1 and then test 2. And I configure job not touching my project at all. So my test 1 and test 2 will run in parallel in job. This, I believe, is what we discussed before using the duplicated job, which is parallel job. Yeah, let me know if this doesn't, if you want to elaborate a little about the use case, if this is not the duplicated job. Just raise your hand and I can let you speak here. All right, moving on to the next question. What type of pipelines would you recommend for a project where we would like to trigger different tests and build tasks depending on which files were changed? For example, distinguished by file type or path. Parallel jobs would be also nice to have. Yeah, I think this is what the keyword change is for, and you can check where the changes were made, and based on that, run certain jobs or not run them.
If I can chime in, so there's something I already shared, I think, in the Q&A session earlier today in chat, but I think this is one of the very, very well requested features that we are hopefully delivering 14.3. I think it's now scheduled. what we call conditional includes. What this means is that right now, of course, we all know that you can use rules to, for example, to set, to customize a job only to run when a specific file is changed. Now, what we're adding in the coming releases is the ability to run conditional includes. So what this means that you would be also, when you include another, let's say, external GitLab CI definition, you would soon be able to provide rules upon which that file can be included. That would allow you in your main GitLab CI YAML file to create a number of these conditional includes, and then sort of keep separate files where separate logic is defined. Hopefully that will be helpful in the coming releases for you.
Do we have more questions? I see a couple of questions are answered in the window. We don't have any more questions. We can include here, and we will include all the answers to the questions as well as a better quality video in the follow-up to this webinar.
Cool. So thanks everyone for joining. See you on the next webinar. As Osnat mentioned, we'll also send some information on how to contact us if you have more questions about CICD. In the meantime, enjoy the rest of your day and see you next time.
Thank you.